A matrix is a what? What did we say a matrix is? A set of numbers that what? That are arranged in a rectangular manner. Full stop. That are arranged in a rectangular manner. Full stop. Example. We can have something like this, 2130, comma. We can have something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Something like this. We can even have this. Too. Like that. etc. Are we there? Oh, you're right. If you're done with that example, you're right. The elements of a matrix are usually not separated by commas. The elements of a matrix are usually not separated by commas. By commas. The elements of a matrix are usually not separated by commas. Have you done that? Full stop. Are usually not separated by commas. Full stop. Oh yeah, listen up, class. Listen up. So we are talking about a matrix. What did we say a matrix is? Let's read once already. Go. A matrix is what? Good. So when we talk about a matrix is not one complex thing like that. Okay, even though in an advanced way, matrices can be very complex. But at this point, a matrix is just a rectangular arrangement of numbers. Rectangular what, class? So if I have, let's say I have 1, 2, 3, 4, 5, and 6, something like this. And I don't want to arrange them like this. And I say, okay, let me arrange them in a rectangular way. So I can have something like this, 1, 2, 3, 4, 5, 6. Now, arranging them in this rectangular way, this is what we call a matrix. This is what we call a what now? I can also decide to write it like 1, 2, 3, 4, 5, 6. This is also a matrix. So arranging numbers in a rectangular way, this is a rectangular way, this is a rectangular way, this one is also a rectangular way. So when you write a single number, it is actually in a rectangular way. So writing numbers this way is actually a matrix. Now, one of the problems that students have is you ask yourself, all this topic we are doing, where is it even applied? Now, as a simple thing, imagine you're going to go and do computer science. Let's say computer science is the course you want to go and do. Where will you apply matrices? In image analysis. When you are doing image analysis, you see that an image, that is a picture. Let's say you have a picture, and in that picture, this is you, this is your mother, and this is your father. In that picture, this picture is basically a matrix. That is, in a mathematical way, this picture is a matrix. Okay? A very, very huge matrix. So, as a computer scientist, you are going to do image analysis, which is basically matrices. You want to go and do economics, no problem, in school. As an economics student, you are going to do econometrics, which is a course. Okay? And in there, you are going to be analyzing what? Matrices, and so on. There are so many applications of matrices. And as we move on, we are going to be seeing them. So, class, whenever we say matrices, what did we say matrices are again? It is the what? Arranged in what? In a rectangular manner. Or in short form, you can simply say rectangular arrangement of numbers. Rectangular again now. Arrangement of numbers. That is what a matrix is. Now, let's continue. Order of a matrix as a subheading. Order of a matrix. Order. O-R-D-E-R. Order of a matrix. Order of a matrix. Are we there? Order of a matrix. Now let's write. Let's write. Recall that a matrix is the rectangular arrangement of numbers. Recall that a matrix is the rectangular arrangement of numbers. Recall that a matrix is the rectangular arrangement of numbers. Recall that a matrix is the rectangular arrangement of numbers. Are we there? Full stop. Full stop. This means that numbers are arranged horizontally and vertically. This means that numbers are arranged horizontally and vertically. This means that numbers are arranged horizontally and vertically. This means that numbers are arranged horizontally and what? Vertically. This means that numbers are arranged horizontally and vertically. Full stop. Now write. The horizontal arrangement of numbers, the horizontal arrangement of numbers, the horizontal arrangement of numbers are called rows. Are called rows. R-O-W-S. The horizontal arrangement of numbers are called rows, while the vertical arrangements are called columns. The horizontal arrangements are called rows, while the vertical arrangements are called what? Columns. Full stop. Full stop. Full stop. The order of a matrix simply means, the order of a matrix simply means, the order of a matrix simply means, the order of a matrix simply means how many rows and columns the matrix have. How many rows and columns the matrix have. How many rows and columns the matrix have. The order of a matrix simply means how many rows and columns the matrix have. Idegia now. Have you written it? Good. Full stop. Now right. If M is the number of rows, if M is the number of rows and N is the number of columns, if M is the number of rows and N is the number of columns, then the order of a matrix can be written as M times N, like this on the board. Then the order of a matrix can be written as M times N, like this. Are we listening? Are we listening? Oh yeah, pay attention, class. When you say M times N, that is not how you read it. That we wrote M times N does not mean that is how you say it out. For you to say this out, you say M by N. You say what? So this times becomes by. We don't say times. We say what? By. So this is M by N. Good. Oh yeah, again to now. Order of a matrix. I want you to pay attention, even though you already know matrices. Trust me, you don't know matrices. We are coming. Now, I want you to understand all the basics so that you don't get confused now. Class, when we talk about order of a matrix, what do we mean by that? Now, when we say matrix, we already said that a matrix is a rectangular arrangement of numbers. Let me say I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, look at the arrangement of all these numbers. Now, if you look at these numbers, you see that they are arranged horizontally. We have horizontal arrangement and we have vertical arrangements. Are you with me, class? So what are the horizontal arrangements here? Can you tell me horizontal arrangements here? What are they? 1, 2, 3. Which other one? 4, 5, 6. Which other one? 7, 8, 9. Oh yeah, what are the vertical arrangements here? 1, 4, 7. 2, 5, 8, and what? 3, 6, 7. Sorry, 3, 6, 9. Now, but we don't say horizontal and vertical. We call it rows and column. We call it what now? Rows and column. So which ones are called rows? Horizontal. What did we say? So the horizontal are the rows. So if I say what are the horizontal arrangement, we don't usually say horizontal. I will say what are the rows. So what are the rows here, class? 1, 2, 3. 4, 5, 6. 7, 8, 9. Then when I say the vertical, instead of saying vertical, I say what? Columns. So what are the columns here? 1, 4, 7. 1, 2, 5, 8. And what? 3, 6, 9. So this is our columns and this is our rows. So we now said that for you to say the order of a matrix, that the order of a matrix simply means how many rows and columns are in that matrix. So, kedu order of this matrix? What will you tell me? 3 by 3. Not 3 times 3. You will say what? Now, this 3 by 3 means it has 3 rows, 3 columns. So, when you are saying the order of a matrix, you start with the guinea rows. You start with the what, class? The rows first. And what are rows again? Is it vertical or horizontal? So you start with the horizontal, which is the row, and then the column. That is what I meant by this statement. If M is the rows and N is the columns, then the order is M by N. So rows, column. Huh? Now look up. So class, look at an example. We say, look here, 2, 3, 4, 5, 6, 7. And I ask you, what is the order of this matrix? Is it 2 by 3 or 3 by 2? Which one? You say 2 by 3, say I. You say 3 by 2, say nay. You don't know the answer, say who, ha. You must belong to one category. Who are those that, hey, I said, okay, 2 by 3, you said I, Abi? F9. 3 by 2 is the answer. Why is it 3 by 2? I said, which one comes first? Rows. So how many rows can you see here? 1, 2, 3. Are we are now? How many columns? 1, 2. We have not started using matrices, and you are failing already. So this is a 3 by 2. Are you with me? Don't say, if you say 2 by 3, this is a different thing, meaning it has 2 rows and 3 columns. So, but this one is 3 rows, 2 columns. Are you with me? Should I give another one? Again, what we are? Okay. 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 What is the order of this matrix? 1 by again, Is he 1 by 4? Am I hearing 4 by 4? Okay, so this is 1 by 4, meaning 1 row, how many columns? 4. 1, 2, 3, 4. 4 columns. Oh yeah, look at this one. Let me hide so you not see it. Have you seen it already, have you? Okay, don't worry, don't worry, don't worry. Okay, so I do this. I do this. What is the order of the matrix? Eh? Is it 5 by 4? Meaning 5 rows and what now? 4 columns. So 1, 2, 3, 4, 5. These are the rows. Then columns 1, 2, 3, 4. Do we get that now? Good. Oh yeah, 1 more or maybe 2 more. We now continue. Class, what is this one? Eh? Is it 2 by 1? So this is 1, 2. 2 by again 1. So 1 column. Okay, another one, another one, another one, another one, another one, another one. Eh? 2 by 3. For your mind, okay, let's continue. So we are done with order of metrics. Let us now see where this thing can be applied. Now, right. Position of elements in a matrix. 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 Position of again now. Elements in a matrix. Now, I need to be telling you why we are doing certain things. Omo mmadụ ngwa na matrix anya. Where de 3, 1, 7, 4, 5, 2, 3, 1, 0. Look at this. What is the order of this guy? This is a 3 by 3, right? Now, if I ask you about elements 3, this element, if I say identify 3, you'll be like, is it this 3 or be this 3? Because you see that this 3 and this 3 are identical, but are they in the same position? They are not. So we need to know how to identify position of elements in a matrix. So, have you written position of elements? Oh yeah, let's write. An element in a matrix can be identified. An element in a matrix can be identified using the row number and column numbers. An element in a matrix can be identified using the row numbers and the column numbers of the matrix. Using the row numbers and the column numbers of the matrix. Using the row numbers and column numbers of the matrix. Using the row number and column number of the again now matrix. Using the row number and column number of the matrix. Consider a matrix shown below. Consider the matrix shown below. And I'm just going to put A, B, C, D, E, F, G, H, I. Let's just leave it like that. These are our matrix. These are our matrix. So consider a matrix A, B, C, D, E, F, G, H, I. So we have this. Now, pay attention, class. Our task is to identify the positions of all the elements here. And we said that for you to identify the position of an element, we use the rows and column number. Rows and again now. Pay attention now, because I will not say it twice. Again, take it out, because next is question. Class, if you look at A, this element A, and Mado Juogi, Kedebe A no. Which row does A belong to? Which row does A belong to? First row. And which column does it belong to? First column. So the position of A becomes 1, 1. So this is A, 1, 1. 1, 1 meaning first row, first column. Huh? Huh? Obanye. Obanyero. Bab that hair, in fact. Bab your hair so that the breeze will carry the book and enter. Now, Gekwenti again. Gekwenti again. If you look at A, we have not even gone to B, C, and others. A is in the first row. This is the first row. And A also belongs to the first column. So in order for us to say, instead of writing A is in the first row and first column, we say A, 1, 1. 1 meaning first row. The other one is first column. So using the same idea, what subscript will be on B? 1 again. Is he 1, 2 now? Why is he 1, 2? First row, second column. This one is what? 1, 3. Oyankab again. Is he 1, 2 or 2, 1? Meaning, remember, row first. Nkab again. 2, 2. Nkab again. Nkab again. Nkab again. Nkab again. 3, 3. So that is how you identify the elements. Now, let's assume we have another matrix. I'm just giving an example. Let's say you have X, Y, Z, W, P, R, something like this. Let's identify their position. X, gabogene. Is he 1, 1? Nkabogene. 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 Good. Do we understand that, class? Good. Oh yeah, you can take it down. Take it down. And let's continue. Just make sure that you are following. Very important. Very, very important. If you are not following, you tell me, like that girl said it was not entering. So you tell me when it is entering and when it is not. Auntie? Obanyekwe. Okay. Can I go on? Can I go on now? Okay. Now, types of matrices. Types of matrices. Types of matrices. I'm sorry I'm boring you with these parts. But it is very, very important if you will understand this. But we have to just do it. Are we ready? What did I say you should write down? Types of matrices. Now pay attention. There are plenty types of matrices. In fact, if we start, we will not be able to finish it. So the ones I am going to tell you about are those important ones you need to know, because you are going to be seeing them more frequently. Is that okay now? You are going to be seeing them frequently. That is why we'll talk about those ones. So right, number one. Let's start with number one. Number one, square matrix. Square matrix. Square matrix. Bam, bam. Square matrix. Are we there? Oh, yeah, right. Square matrix. It is a matrix that has equal number of rows and columns. It is a matrix that have equal number of rows and columns. It is a matrix that have equal number of rows and columns. It is a matrix that have equal number of rows and columns. It is a matrix that have equal number of columns. Are we there? It has the order. It has the order M by N. Of course, you know how we write that. M times N. It has the order M times N, where M equals N. Where M equals N. Remember, class, if I tell you that the order of a matrix is M by N, what does M represent? Rows. And N represents what? Columns. Good. So we said that a square matrix is a matrix that have equal number of rows and again now column. So if I say something like 2 by 2, a 2 by 2 matrix, is it a square matrix? A 3 by 3 matrix, is it a square matrix? A 4 by 4 matrix, is it a square matrix? What about 5 by 5? And so on. So once the number of rows and columns are the same, what kind of matrix do we call that? Square matrix. Are you with me, class? Diagrammatically, you can see something like this. This is a square matrix, but what is the order? 2 by 2. Now, 3, 4, 5, 6, 7, 8, 9, 10, 11. What about this guy? 3 by 3. Is he square? Yes. So a square matrix is that it will have equal rows and equal columns. As simple as that. Huh? Oh yeah, let's go on. Number again now. Number 2. Number 2. Row matrix. Row matrix. Row matrix. Are we there? Oh yeah, right. It is a matrix that has only one row. It is a matrix that has only one row, but can have several columns. It is a matrix that has only one row, but can have several columns. It is a matrix that have only one row, but can have several columns. But can have several columns. Full stop. Full stop. It has the order M by N. It has the order M by N. It has the order M by N, where M equals 1. Where M equals again now 1. Where M equals 1. Full stop. So class, what is a row matrix? A row matrix did what? A matrix that has only one row, but can have what? But can have several columns. Good. Now, what do I mean by that? Look at example. A matrix that is 1 by 2. Is it a row matrix now? How do we know it is a row matrix? Once it has one row. One row. Ofugene, row. Once it has one row, it is a row matrix. Okay? 1 by 3. 1 by 4. 1 by 5. It can even be 1 by 1 million. It has, once it has only one row, we call it a row what now? Matrix. You can see something like this. Let's say we have 1, 2. What is the order of this guy? 1 by 2. How did you get the 1 by? Is it 1 and 2? Okay. What about this one? 10 minus 11. What is the order of this guy? Is it 1 by 2 now? So what kind of matrix will you call this? Row matrix. A row matrix. If I have 10 minus 11 and 2, what is the order of this guy? 1 by 3. And is it also a row matrix now? Yes. Good. All right, let's continue. Number what now? Number 3. Number 3. Column matrix. Column matrix. From what I told you about row matrix, can you tell me what this one will be? The one that has only what? One column. Okay, huh? Oh yeah, let's write it down. It is a matrix which has only one column. It is a matrix which has only one column. It is a matrix which has only one column. It is a matrix which has only one column, but can have several rows. But can have several rows. But can have several rows. Can have several rows. But can have several rows. Are you there? But can have several rows. Idegia now. Good. It has the order M by N. It has the order M by N, where N equals 1. It has the order M by N, where N equals 1. Where N is equal to 1. Where N is equal to 1. Where N is equal to 1. Have you done that? Good. Of course, you can see the examples. Class, when we say a column matrix, we said that it is a matrix that has only one column. So if I say something like 2 by 1, is it a column matrix? If I have something like 3 by 1, is it column? Good. 4 by 1. So all these things are examples. Things like this. If I have 2, 1, is this a column matrix? Is this a column matrix? How many columns are here? 1. If I saw something like this, 0, 11, 10, what kind of matrix is this? This is a column matrix. It has 3 rows, but 1 column. So once the number of columns is 1, it is a column matrix. Once the number of rows is 1, it is a what? Row matrix. Just like that. And it's very important you know that a column matrix is also called a vector. It's also called a what now? It's also called a vector. Because this is how we write down vectors mathematically. Don't worry, we might come to that. Okay? So a column matrix is also called a vector. Now, there is one more type of matrix we'll talk about before we proceed. Like I told you before, there are several types of matrix. There are several types. Now, number 4, identity matrix. Identity matrix. Identity matrix. Identity matrix. Are we there? Oh, yeah, right. It is a type of square matrix. It is a type of square matrix. It is a type of square matrix. It is a type of square matrix where the elements on the major diagonal, where the elements in the major diagonal is 1. Is 1. O-N-E 1. Is 1. While other elements are zeros. While other elements are zeros. 0, 0, 0. While other elements are what now? Zeros. Full stop. Example. 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 Before I give you an example, I want you to understand what we have said. Class, what is an identity matrix? Let's read 1, 2, ready, go. You are not reading. You are not reading. What is identity matrix? Again. Hi, Jesus Christ. Jesus, Jesus, Jesus. I know you are hungry and tired, but the Lord is your strength. You don't have to say amen. The Lord is your strength. Good. And even the Bible says that man shall not live by what? Yes. Oh yeah, let's read. 1, 2, ready, go. The choir is not organized. 1, 2, ready, go. Good. Oyagente, before I give example, class, first of all, we said that an identity matrix is a what? A square matrix. Meaning that the first condition for you to call something an identity matrix is that it must be a square matrix first. So if it is not a square matrix, then it can never be what? An identity matrix. Remember what square matrix is, Abi? What is a square matrix again? It has equal number of rows and what? Columns. Oh yeah, listen up. The only thing that you might not understand here is major diagonal. Class, whenever we have a square matrix, please pay attention. I have A, B, C, D. This matrix, is it a square matrix? What is the order? Now, in this square matrix now, we have what we call major diagonal and minor diagonal. Class, the same thing is applicable in your rectangle. When you draw a rectangle, when you draw a diagonal from this end, this is upper right. Upper right. So if I draw a diagonal from the upper right to the lower left, like this, this diagonal is called the major diagonal. It's called the what now? Major diagonal. Then if I draw, Abi? No. This is the minor, please. This is the minor. This is the minor. Sorry for that. You know, when your head is upside down like this. Please, this is minor diagonal. Okay? So when I draw a what? A diagonal from the upper right to the lower left like this. This is called the minor diagonal. Then the one I draw like this. What is this side? What is this side, class? Upper word, left. To lower word, right. So if I draw here, this is called the major diagonal. This is called the major diagonal. So whenever you draw a rectangle, that is what you must know. So the same thing is applicable to a square matrix. So in a square matrix, line now, anybody that falls on that line is on the major diagonal. Is on the beginning now. And then if I draw this one, these ones are the what now? Minor diagonal. So class, which elements are on the major diagonal here? A and D. Which elements are in the minor? C and B. Now, this is for a 2 by 2. The same thing is applicable in a 3 by 3. Let's say I have 1, 0, 11, A, B, C, D, E, F. Like this. Which elements are in the major diagonal here? Is he one BF now? One boyfriend, right? Jesus, what happened to Jesus? Now, which elements are in the minor diagonal here? 11B, there B. Good. So this is my minor diagonal and this is my major diagonal. That is how it happens. Class, if I have A, B, C, D, E, F, which elements are in the major diagonal? Which elements are in the major diagonal? A and what? A and A and what? A and again, you must talk. A and B. Is it none? Because you cannot talk about major and minor diagonal here. Here, square matrix. So you cannot, if you go and draw it, somebody will be out of that line. So you cannot do this when it comes to this kind of matrix. What is the order of this matrix, class? 2 by 3. Is it 3 by 2? Good. So in this type of matrix, it is not a square matrix, so you cannot talk about square. You cannot talk about minor or major diagonal. So back to identity matrix. So we now said that identity matrix is a matrix where all elements in the major diagonal is 1 and other elements are what? 0. Oh yeah, pay attention now. An example is a 2 by 2 identity matrix. So look at how I will write the 2 by 2 identity matrix. So remember, for a 2 by 2 matrix, what elements or how many elements will it have? How many elements will be there? 4. So first of all, I will write all the elements in the major diagonal. 1, 1. Then other elements are 0. So this is a 2 by 2 identity matrix. Okay? So this can be written as 2 by 2 I. In JAMB or WAEC, they will not give you this thing. No. They will just give you I, where I is a 2 by 2 identity matrix, or where I is a 3 by 3 identity. So it is left for you to know how to write 2 by 2 identity, 3 by 3 identity, even 4 by 4. Oh yeah, let's write 3 by 3. Class, 3 by 3 matrix. What do you think it will look like? First of all, you don't have to cram anything. Just remember that definition. All elements in the major diagonal must begin 1. Every other element is what? 0. So for a 3 by 3, how many elements is supposed to be there? How many elements are supposed to be there? 9. So we are going to do 1, 1, 1, like this. Then fill every other thing with 0. How many zeros should be here? 2. This. How many zeros should be here? 2 also. 1 here, 1 here. Yeah? How many zeros should be here? 0, 0, 1. So this is a 3 by 3 I. Can you write 4 by 4? Oh yeah, 4 by 4. Let's write 4 by 4 and see how it will look like. 4 by 4. 1, 0, 0, 0. Are we here? Are we here? Okay, what next? 0, 1, 0, 0. What next? 0, 0, 1, 0. Are we here? Then next is what? 0, 0, 0, 1. So that everything here is in the major diagonal. Yes. So that is how you write it. Oh yeah, let's try one more. 5 by 5 identity. 5 by 5 identity. If you don't know it, shut up. If you know it, 1, 2, ready, go. 1, 0, 0, 0, 0. 0, 1, 0, 0, 0, 0. 0, 1, 0, 0, 0, 0. 0, 0, 0, 1, 0. 0, 0, 0, 0, 1. So that everything here is in the major. Now. Then every other thing is 0. That is how you write identity matrices. So, but of course, going 5 by 5 will be too much for you. Even 4 by 4 is too much. So at this level, JAMB will just be playing with 2 by 2 and what? 3 by 3. But when you enter the field, when you now start doing engineering or maybe whatever you want to do, and you start seeing matrices there, you will even see large matrices. You might see 10 by 10, 20 by 20. Okay, those ones, you know, you write it in book. Yes, now, you will not write those ones, or maybe you can see 100 by 100 identity. You cannot write that one in book. That one, you just press it in computer. Computer take care of it. That one, you cannot do it by yourself. Okay, so take this down, this and this, very important, take it down. So 2 by 2 identity, 3 by 3 identity. Before I continue, can you nega ajụjụ? Can you nega ajụjụ? Unwe sigi that A is equal to 2 minus 1, 0, 4, 3, 1. And B is equal to 7, 5, minus 2, minus 1, 0, 1. Something like this. This is A and this is B. Class, I now say you should do something like this. That you should find A23 times B11. Can you solve that? Do you think you'll be able to do that? Do you think you'll be able to do that? Oh yeah, try. Wait till be the answer. Wait till be the answer. Wait till be the answer. You don't know how they got the 7. Answer. Say hi. You don't know how they got the 7. Say hi. Don't be shy. Say hi or say so. Now, oh yeah, pay attention. That means you have forgotten what this means. If I say A23, what does it mean? Element in the words, second row, third column of A. So which element is in 2, 3 in this matrix? 1. 1 times 1, 1. First row, first column. Which element is in B11? 7. So 1 times 7 is what? Did you follow? What if I say you should do? What if I say you should do? A21 divided by B13. What will be the answer? What will be the answer? Check it, check it. What will be the answer? What is A21? What is A21? Is it 4 divided by, what is B13? Is it minus 2? I have minus 2. So 4 divided by minus 2 is how many? Minus 2. Okay? So it just occurred to me that we did not solve questions when we talked about. That was why I had to bring you back. Okay? She's still not following. Oh yeah, one more example. This one is for you. Nobody should answer. For you. Yes, for you. For you. Especially for you. Where say A22 plus B22. So what is in A row 2 column 2? What is in A row 2 column 2 there? What is, I was not talking to, I was talking to them. So what is in A22? If you come to the matrix A, what is in 2-2 position? 3, Abi? You put it down. This is 3. Plus, if you come to B, which one is in 2-2 position? 0. So 3 plus 0 is how many? 3. Do you grab now? You don't want to say thank you? Okay. Okay, oh yeah, should I give another one? Should I give another one? Oh yeah, another one, so that we can proceed. We can proceed. Okay, let's say that X is equal to 419, 231, 011, 7. And then Y is equal to minus 1, 0, 2, 4, 3, 1, 0, 2, 7. Something like this. We find X32 times Y21. X32 times Y21. Can you hear Abo? 44. Now, what is in X32? Is it 11? That is 1, 2, 3. Third row, second column. 1, 2. So this is 11. So I will say 11 times 2, 1. Here under Y is what? Is 4. That is second row, first column. So 4. And this will give me 44. Are we here? That is how to solve that. Okay. What if I say you should find X11 divided by Y33? Where's the answer? 4 over 7. That is this guy divided by this guy. Are we here now? Good. So that is how to identify that. Is that okay, class? Okay. Ngwadelum now kwage addition and subtraction of matrices. Addition and the subtraction of matrices. Addition and subtraction of matrices. Addition and subtraction of matrices. Addition and subtraction of matrices. Are we there? Addition and subtraction of matrices. Oh, yeah, right. When adding or subtracting matrices, comma, 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 corresponding elements are evaluated. Corresponding elements are evaluated. Corresponding elements are evaluated. Corresponding elements are what? Are evaluated. Full stop. Full stop. Now, right. In order to add or subtract two matrices, comma, in order to add or subtract two matrices, comma, in order to add or subtract two matrices, comma, in order to add or subtract two matrices, comma, they must have the same order. 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 They must have the same what now? They must have the same order. They must have the same order. Oyagente, let us explain what we've said so far. We have not started doing anything, but you need to understand the rules. Class, the first thing you need to know is that before you add or subtract two matrices, both of them must have the same order. Both of them must what? Both of them must have the same order. Now, what do I mean by that? Obu na nwe A equal to, let's say, 2, 1, 4, 3. And B is equal to, let's say, 2, 1, 3, 4, 1, 7. Something like this. I cannot add A and B. I cannot add both of them. It's not possible. Just like Paul and Paul cannot marry. Abi? Can Paul and Paul marry? In this generation, can Paul and Paul marry? He said, yes. So I can make you love. I can make you love. Yes, yes, yes. If a poor man comes for you now, will you marry? Okay, forgotten. Okay? So you cannot add two matrices that don't have the same order. The same thing, you can also not subtract both of them. Class, what is the order of this guy? 2 by 2. What is the order of this guy? So this is 2 by 3. You cannot add both of them. For you to be able to add both of them must have the same order. Are you with me now? Good. So apart from that, next thing you need to also know is that when you are adding matrices, all you normally do is you normally add the corresponding elements. You normally do what now? You add the corresponding elements or evaluate the corresponding elements. For example, Obunasimu A plus B. You see that I can say 2 plus 2, 4 plus 4, 1 plus 1, 3 plus 1. But what will you now add to this one? So you cannot do that. Do we get that now? Eh? Did somebody say no? Better don't say no. Better don't say no. Because the kind of hunger that is holding me now will bite you. Oh yeah, write down examples. Let's look at examples. Don't worry, when we solve examples, you will understand it. Examples. Are we there? Okay. Example 1. Just let's start with something very simple. Class, x is equal to 2 minus 1, 3, 0. And y is equal to 4, 7, 11 minus 3. They now said we should find x plus y. They said we should find x plus y. They said we should find x plus y. So our x is 2 minus 1, 3, 0. plus our y is 4, 7, 11 minus 3. Oh yeah, class. The answer will also be a 2 by 2 matrix. So let us add. We said we normally do or evaluate the corresponding elements. So 1, 1 and 1, 1. 1, 2 and 1, 2. 2, 1 and 2, 1. 2, 2 and 2, 2, 2. Just like that. So correspondingly. So class, 2 plus 4 will give me what? So I will have 6 here. Minus 1 plus 7 will give me what? 6. I have 6. 3 plus 11 will give me what? 14. Then 0 plus minus 3 will give me what? Minus 3. And that becomes our answer. Was that difficult? Good. Remember, when you give birth to a baby, do you rush and give the baby apple? You don't rush and give the baby apple, Abi. It is with time you will start. Did your parents give you apple on the first day? You would have died, nah? You would have died. They cannot give you apple on the first day. So they will start with breast milk first. Then with time, after some months, you will now start taking all the artificial ones. And then akamu also. By 5, 6 months, you will now be eating gari and rice. They will introduce you to the gari. Before they say that gari is poor man food. Now, now, you are no dogu. Ego Nebu is the penta of gari. Olugo 2000. 25. Ah, God. I remember those days while we were in school, when Goodluck Ebele Jonathan was still the president. If you give me 2,000 then, I will go to the market and charter food stuff. Yes, those days, if I'm going back to school like this, after hustling, I will hustle like 5K. 5K is like big money. I will go to the market, I will buy like 3 pentas of gari. I've never spent up to 1K. Because penta of gari then was 250. White was even 200. White was 200 naira. I'll buy that. I will use 1K and buy biscuits, cabin biscuits. Buy like 4 to 200. Then it was even, what was the name? You know, there's cabin and there's Yale. Yale was 170 those days. And then Oxford was 200. So we buy like Yale. We know they do 200 naira one. So we save money. We now buy, I'll buy like 5 and enter school. Buy rice. Rice was still cheap then, 500 or so. Buy beans. Buy all the oil and the Maggi. If you enter my kitchen like this, I will tell you that this is 5K. You'll be like, ha, I don't go market too. But now, now, if you enter market with 50,000, you will not see anything. You will not see anything. And those days, if you have up to, let's say you have up to, let's call it 7K or maybe 8K, you will even buy a carton of Indomie and join. And be enjoying Indomie. But Keta, even the whole 8K cannot buy you Indomie. One Indomie is now 500. It's not 500 now. 500 naira. Indomie. What would we do? Belefu is now 1K. Oh, 1, 2. I beg, show us your street. Let's be buying it 1K. Yeah. So things are now, in fact, it's no longer. I was scrolling through TikTok, and then there is this song that, I don't know who sang that song, whether it's Agatha Moses or somebody. By the grace of God, I shall win this battle. You know that song? And in the song, she was saying, even if they lie, let them sell a bag of rice for 7,000. That will still survive. And that song was ancient musical, like 2000, 2001 music. So somebody brought the song back. And then we're like, I beg, where are they selling it for 7K? We'll buy. We'll buy. Because bag of rice, you know what bag of rice is now? Almost approaching 100K. It's approaching 100K. And somebody is saying, if the lighter then say bag of rice 7K, show me. And I'll buy 10 bags. I'll buy 10 bags. Okay? Oh yeah, number 2 example. Y is equal to minus 3, 4, 0, 2, 1, 9. And then W is equal to 1, 2, 4, 7, 0, 3. Like this. And they said you should find in I, they said you should find Y plus W. And then II, they said you should find Y minus W. Can you solve that? Oh yeah, be doing it. Be doing it. Be doing it. Be doing it. No go again the wire can jam, but bro, Mondays equals nkende is golumu. Now addition again, man. Go down here. So I will now go and write Wayeki again. When I wrote Wayeki, we were still in primary school now. I wrote Wayeki in 2014. Where were you in 2014? Obviously, you were in primary school. Was anybody in nursery? Okay, it's not like 2014 was even far. That was 10 years ago now. That was 10 years ago now. But 10 years is far. Forget. 10 years is far, guy. Okay? 10 years is a very long time. A very, very long time. A lot of things can happen in 10 years. Abi? So by the time you add 10 years to your life now, you have like 2 children. By then, Abi? Daddy Junior. Or Mommy Nkechi. Mankechi. Daddy Alex kwa. Abi Alex Junior. It be Alex Junior now. Yes, do we have an answer? Okay, what did you get for the first one? Minus 2, 6, 4, 9, 1, and 12. What did you get for the second one? Minus 4, 2, minus 4, minus 5, 1, and 6. Good. That's very nice. That's very, very beautiful. Very, very beautiful. Okay? That is why most times they don't ask you addition and subtraction, because they know you will just correspondingly. Okay? But don't worry, let's continue. Let's be going. Let's be moving forward. Let's move forward. Yes? Number 3. Number 3. I will say that P is equal to 170,214 minus 1 minus 30. Something like this. And Q is equal to 111,011,311. Like that. A way to find 2P minus 3Q. Is it possible? Oh yeah, sharp, sharp. Find 2P minus 3Q. You know, do you know what that means? Do you know what 2P means? Do you know what 3Q means? Oh yeah, I'm going around though. when I gather my energy. I remember those days preparing for WAEC. It was, in fact, the day I collected the money for WAEC from my mother, my sister also collected her own. My mom asked us, "Ungwajide nunti unu?" We held our ears. She said, "If you fail WAEC, Emma, carpenter. Chinyere, sewing." That was what she said. Now be person tell us more, we'll go read. Sometimes you need to be threatened. Your parents need to threaten you before Ibauru. Do we have an answer now? Eh? I'm still waiting. Don't worry. Uh-huh. Do we have an answer now? La 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 la. Pam pam pararam. Pam pam pararam pam param pam param. Pararam pam pararam pam 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 pam. Param pam. Tan 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 tan. Tan 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 tan. Tan tan tan. Tan 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 tan. Tan 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 tan. Tan 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 la la. Oh, you know the song? Tom and Jerry, yes. This good old days. Enjoyment everywhere. Okay, oh yeah, let's get the answer together now. Let's get the answer. We said 2p minus 3q. Oh yeah, class. 2p means, first of all, you should use 2 and multiply p. Okay? Oh yeah, let's multiply. 2 times 1. 14. 0. Here's how many? 4, 2, 8. And here's what? Minus 2, minus 6, 0. Minus, use 3 to multiply that one. What do we have? 3, 3, 0, 3, 3, 9, 3, 3. Oh yeah, let's do the maths now. Minus 1. Is it minus 1? 11, minus 3, 4, minus 1, 5, next. Is it minus 9? Minus 3. Now, even though plus and minus can be very simple, at the same time, you have to be careful. You have to begin it now. Careful. Because the worst thing that can happen to you is when you fail something you are supposed to get. You will be so sad. In fact, you'll be angry with yourself. So you have to be very, very careful. Should we take another example, or do we go to multiplication? Do we go to multiplication? That one is much more difficult. Much more difficult. Okay? No, it's not difficult. Let me not say difficult. It's more tricky. Okay? So you have to be careful with how you multiply. So let's write multiplication of matrices. Multiplication of matrices. This my marker is no longer writing very well again. Do we have extra markers? Alex. You did not see again? Okay. Is that one writing? Okay, find a way and refill this one. Do you have refill? Okay. Multiplication of metrics. Are we there? Oh yeah, let's write. Let's write the things you need to know. Oh yeah, right. In order to multiply two matrices, comma. 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 Are we there? In order to multiply two matrices, comma. The number of columns in the first matrix, the number of columns in the first matrix, the number of columns in the first matrix, the number of columns in the first matrix must be equal to the number of rows in the second matrix. The number of columns in the first matrix must be equal to the number of what? Columns. Sorry, rows in the second matrix. The number of columns in the first matrix must be equal to the number of rows in the second matrix. Have you written that? Full stop. Full stop. Now, class, that is the only condition you must know. You know, remember that I told you when you are adding or subtracting, I said that for you to add two matrices, they must have the same order. Good. But when you are multiplying, sometimes they will have the same order, but it's not possible to multiply them. It's not possible. For example, I cannot multiply a 2 by 3 matrix and a 2 by 3 matrix. I cannot multiply them. It is mathematically impossible. It is not possible. So, when you are multiplying two matrices, we said you must hold a particular rule. You must follow a particular rule. And what is that rule? Pay attention. Class, let's assume that the matrix A has an order of M by N. The order of the first matrix is M by N. And the order of the second matrix is X by Y. The order of the second matrix is X by Y. Class, how many rows does the first matrix have? I'm asking, how many rows does the first matrix have? Is it M? How many rows does the second matrix have? X, just like that. Now, we now said for you to multiply, make sure that the number of columns in the first matrix is equal to the number of rows in the second matrix. What does that mean? This guy and this guy should be equal. So N must be equal to what now? X, for you to be able to multiply them. So for example, looking at this, why did I say you cannot multiply both of them? How many columns are here? How many rows are here? 3 and 2, are they the same thing? They are not the same, so you cannot multiply them. That is what that rule is saying. You cannot multiply. Now, let's say you have a 2 by 2 matrix. Can I multiply a 2 by 2 matrix and a 2 by 2 matrix? Can I multiply them? Because this number here is equal to the number here. So this is what I normally do. I was the one that developed this short method for myself. Before I multiply them, I will write out the order. Once I write out the order, I will circle the last here and the first. If both of them are equal, then I can multiply. If both of them are not equal, I cannot multiply. So, if I ask you 3 by 2, can I multiply 3 by 2? Eh? Can it multiply? No. Because this number and this number, they are not the same. These 2 here represents column. These 3 here represent what? Row. So they are not the same, and because of that, we cannot multiply. Class, 1 by 4, can I multiply with a 4 by 1? Yes. I can multiply because this number of columns here and the number of rows are already equal. Please, have you refilled that one? Okay. You should have collected it now so that you can refill this one also. What is in the mad self? Now, so these ones can be multiplied. What if I say a 2 by 3? Can I multiply it with a 3 by 2? I can multiply because this and this are equal. Are you with me now? I have seen a jam question, I think in 2019 or so, where they asked, they said, two matrices, they said P of order P by Q. The first one has an order P by Q. Second one has an order, I think M by S, something like this. They now said the matrix P and the Q are multiplicable. Are multiplicable if option A, P is equal to S. B, Q is equal to M. C, Q is equal to S. D, M is equal to S. What would you answer here? Q is what? Is it Q is equal to M now? All you just need to do after writing it down, circle, circle. So the condition for you to multiply is that these two must be what now? Equal. Do we get that now? There's one more question they will ask. Class, you need to also know the order of the answer. The order of the beginning now. The order of the answer. Class, once you have circled whether it is possible, any other thing that is remaining is the order of the answer. So class, if I have 2 by 3, can I multiply it with a 3 by 2? Why? Because this 3 and this 3 are equal. The order of the result is a 2 by 2. 2 by 2. How did I get it? What is left after circling? Eba Aketa, they can rephrase this question and say, if P and the Q are multiplicable, what is the order of the results? So the options are not here. What will be the order of the results? P by what? S. This is the order of the results. Are you with me? These things will make sense when we start solving examples. Now, oh yeah, another one. Kanju kenegi now. Kanju kenegi another one. Unwesigi that's 3 by 2, a 3 by 2 matrix. Can I multiply with a 3 by 3 matrix? Is it multiplicable? Why? Because this number and this number are not equal. They are not the same, so you cannot multiply. Class, if I have a 3 by 3, can I multiply with a 3 by 2? Yes. What is the order of the results? How did you get the 3 by 2? Commode this. What is left? 3 by 2. Are you with me now? Good. Everything is not all about going to go and multiply. You need to understand the basics that are there. It is very, very important because it makes you different. It makes you what? Different. It makes you different. Oburo ekuhana multiplication. Yes, I can multiply. But there are some cases where you cannot multiply. So you need to be able to know and tell somebody that it's not possible before you even start. So, let us now see how to multiply. Once you've checked and see if it is possible to multiply, let us now see how to multiply. Right, example 1. Example 1. Example 1. Example 1. So let's see how to multiply now. Let's start with something very simple. Let's say we have A is equal to 1, 2, 1, 0, something like this. And the B is equal to 1, 3, minus 1, 4, something like this. And they said we should find A, B. They said we should find A, B. What does A, B mean, class? A times B. Now, get quente before you start writing anything. Class, when you are multiplying matrices, A, B is not equal to BA. Are you with me? AB is not equal to what? Which means, that is in mathematical terms, it means that multiplication of matrices is not commutative. It's not gaining. Shebi, you've done binary operation. And when you talk about commutative property, what does it mean? The order of arrangement does not matter. Am I speaking too much grammar? Class, A plus B, is it the same as B plus A? Forget matrices. Forget matrices. A plus B, is it the same as B plus A? Yes. Oh yeah, look at this. 1 plus 4, is it the same as 4 plus 1? Yes. 3 times 2, is it the same as 2 times 3? Yes. Good. So you see that when you are multiplying numbers on a normal, forget matrix. If you are multiplying numbers, the order of multiplication does not matter. When you are dividing numbers, let's say 4 divided by 2, is it the same thing as 2 divided by 4? No. So when you are dividing numbers, order of operation matters. That means that division of numbers is not commutative. It's not commutative. So when you are multiplying matrices, AB is not the same as BA. So don't go and say, okay, if they say I should find AB, let me put B first before A. No, and trust me, that thing you will solve is also in the option. So be very careful. Oh yeah, let's write it like this. So we have A, which is 1, 2, 1, 0. And we have B, which is 1, 3, minus 1, 4. Are we there? Now, let's see if it is. Is it possible to multiply, first of all? Is it possible to multiply? What will be the order of the answer? What will be the order of the answer? Do you know how we got 2 by 2? First of all, order of A is 2 by 2, multiplying a 2 by 2. This. Answer will be 2 by what? 2. So looking at this now, let's see how we multiply. Shall we multiply correspondingly? 1 times 1 is what? 1. Abi? 1 times 1 is 1. 2 times 3 is what? 1 times minus 1. Talk now. Minus 1. 0 times 4. And this is your F9 smash. In fact, it's in pataka cable. If you think this is how it is. So please don't do this, because one day, your head will be telling you, do it like this, do it like this. F9. So look at how we multiply. Pay attention now. Class, when we are multiplying, remember, this is the one on the left-hand side. We use the rows to multiply the columns. We use the rows to multiply the columns and add correspondingly. What do I mean by that? Oh, yeah, again now. I will open this guy first. Class, this guy will multiply this guy. This guy will multiply this guy. So row, column. That is how we go. Are you with me? Oh yeah, let's see. I will say 1 times 1. So 1 times 1. Then I will put a plus 2 times minus 1. So 2, let me expand this more. So 2 times minus 1. So what did I do? I said 1 times this. And then this times this. And I put a plus. By the time you solve examples, it would look easier. Now, when I'm done with this is first row, first column. You see? First row, first column. First row, first column. So this is your first row, first column answer. Then we do the next thing. First row, second column. Are you with me now? So we are done with first row, first column. Let's go to first row, second column. Oh yeah, we say 1 times what? 3. There, 1 times 3 plus 2 times what? 4. So I will have 2 times 4. Then next, I am done with the first row. Let me check on with the first row. Let's now go to the second row. Do the same thing. I will say 1 times what? 1. So 1 times 1. Are you seeing where I'm positioning my elements now? Okay, I'm not continuing like that. Why? Because I pay attention to what I'm doing. First row, first column should be somewhere here. First row, second column should be somewhere here. Remember, we did positions before we started doing all these things. Then, second row, first column should be somewhere here. Oh yeah, let's continue. 0 times what, class? Minus 1. So, plus 0 times minus 1. Oh yeah, let's continue. 1 times how many? 1 times 3. That is 1 times 3 plus 0 times 4, which is what? 0 times 4. Oh Oh yeah, our final answer will be what? 1 times 1. 1. And then 2 times minus 1. Minus 2. Minus 2. Oh yeah, 1 times 3. Plus what? 8. 1 times 1. Eba again 0. So 1 plus 0. Here is how many? Plus 0. Oh yeah, final answer is what? Minus 1. 11. 3. And that is our answer. Is it difficult? It's not difficult, it's just tricky, right? Because if you go and make mistake and put another number, you will just be off. Because Five baby. Hey, I go. Hey. Hunger is not a good thing. How will you serve my whole life? Are we ready? Now, get acquainted now. Assuming you were solving in exam, let's say you are doing in WAEC, you can do all these things, very important, so that because WAEC, you have to show all again working. But if it was JAMB, of course, nobody is asking you to show all working. Don't go to JAMB and tell them, therefore, recall that. No, nobody is doing all that. So, if it was JAMB, you see that the way you approach this, from here, you'll be getting your answer sharp. And in JAMB, let me tell you, to save time, you don't even have to multiply everything to save time. Once you multiply and get the first row, check the option. Is there any row that corresponds to that row? Are you with me? You check, is there any row that corresponds to that row in any of the options? If once you see it, move on. Okay? Then, when you will now continue if there is maybe more than one row that has the same thing. Are you with me now? That is how you know. And in fact, that will even help you to eliminate some options. So anyone that is not looking like that, just move on. Sharp. Are we ready now? Number two. Let's say that x is equal to 2, 1, 4, 3, minus 1, 0. Something like this. And y is equal to 1, 1, 3, 4. Is it multiplicable? Is it multiplicable? Check any ano. No. Check any ano. Is it multiplicable? They said you should find xy. Find xy. Is it possible? It is possible. Very, very possible. How do we know it's possible? What is the order of this guy? 3 by 2. Multiplying a 2 by 2. Are we here? So this and this are equal. What will be the order of the answer? Order of the answer is what? 3 by 2. Oh yeah, let us get our answer now. So xy is equal to, oh yeah, class, we go row and column. Row and column. Oh yeah, let's multiply, sharp. We'll multiply and get our answer instead of having to write it like that so that we save time. Now, it's not even to save time. Hunger day, please. 2 times 1 is what? Shebi is 2 times 1. Are we here? 2 times 1 is 2. Plus 1 times 3 is what? You know what I'm doing, right? Row and column. So this is it. We are done with that one. Oh yeah, next one. 2 times 1. 2. Plus 1 times 4. We have 4. I hope you know why I shifted to this side. Do you know why I shifted here? So this is first row, second column. So you shift. Good. Oh yeah, we are done with the first row. We now go to the second word, row. We go to the second row. Oh yeah, second row, sharp, sharp. 4 times 1 plus 3 times 3. 9. Oh yeah, 4 times 1 plus 3 times 4. Aqua 12. Oh yeah, nice one. Last row now, last row. Minus 1 times 1. Minus 1, aqua 0 times 3. Oh yeah, next one. Minus 1 times 1. 0 times 4. Oh yeah, our final answer will now be what? 5, 6, 13, 16, minus 1, minus 1. And that is our answer. Do you understand? Good. But remember, if it is WAEC, you need one more step. Oh. Are you with me? You know, because of hunger, I have to shorten it. In fact, normally, if I'm the one solving, this step is useless. I will just be writing this. Should we try that? Should we try it? That means your hunger is now in gear 5. Please, let's not do it. Why are you calling Alex now? I feel that you guys are bullying Alex. So, Alex, everything, Alex. When I said Papa, you said Papa Alex. Maka, Alex. Onyegebum Nobia, Alex. No, if I say fine boy, you not say Alex. Okay, can we try another one? Okay, please, what is the time? What is the time? 4:56. I wanted to trust you, but I will not trust you again. 4:45. 45, since. Yeah. What is? Jesus. Oh my God. I thought you said 4:40 before. I think say 10 minutes for don't pass. Oh, the time is not rushing. Oh yeah, do this one. Do this one for me. Do this one. A is equal to 134,721. And the B is equal to 2, 1. 2, 1. Is it multiplicable? Is it multiplicable? Is it multiplicable? How do you know it's multiplicable? What is the order of this guy? 3 by 2. What is the order of this one? 2 by 1. So your answer will have what order? Aqua 3 by 1, Kogabo. Oh yeah, get me the answer. Let's see if you know what we are doing. Get the answer, get the answer. Yes, find AB, sorry. Thank you, Yes, because they have to tell you what you should find, though. Find AB. Find AB. Find AB. Find AB. Oh, you have an answer. Beautiful. What did you get, please? 5, 15, 5. Okay, let's confirm that. Let's confirm that. Now, I will say 1 times 2. What is 1 times 2? 2. Akuya? Plus 3 times 1. 3. Then, this is just this. Just like that. 4 times 2 will give us what? Plus what? 7. Oh yeah, 2 times what? 2 times 2 is what? 4. Plus 1. So the answer becomes what? 5, 15, 5. 5, 15, 5. Is that okay? Is that okay? Is that okay? Huh? Okay. You don't understand? Waka there. I say hunger they catch me. They tell me say you don't understand. Oh yeah, one more example, and if you finish this one, whether it's not 5 or 5, we are going. Okay. In fact, this one is password. I call it password. If you get it, you just carry your bag and come and show me on the gate, and you go. If you don't get it, you remain here. Eh? He said? Yes, I will stay here now. Why will I faint? Ha! If I do the one I can do, I go. And leave you. They said P is equal to 101, 321, 4 minus 1, 2. And the Q is equal to 1, 2 minus 1, 3, 0, 1. First of all, is it multiplicable? PQ. Is it multiplicable? Are you sure? Okay. So 3 by 3 and 3 by 2. It is possible. So your answer will have what order? 3 by 2. 3 by 2 are where? Oh yeah, get me PQ. Aquamanagata.